Okay, direct variation. So, a couple of equations we're going to use for direct variation. Uh, First equation, which we're going to use whenever it asks you to give me an equation, the first equation is the one I want you to use, and that's y equals kx. Okay, where k is going to be a number, y and x will still be there, but k will just be the constant. It'll be any number. So anytime it says write an equation, that's how I want it written. Now, secondary equation, which we're going to be using a bit because you might need to find the constant first. So this secondary equation is just one to help you. It's not how I want you to write it, but it's something that can help you. And that's k equals y over x. Okay, so this is just to help you find the constant, but whenever we write the equation, I want you to write it as y equals kx. And then how do we know if an equation is direct variation? Basically, after solving for y, if the equation reads y equals kx, so that original equation, um, where k is any constant, then it's a direct variation. So a few examples here. Okay, is each function a direct variation? And if it is, we need to find the constant of variation. So we basically need to find what that number would be here. So if you look, none of these are solved for y. So we have to solve all of these for y. So in example 1, what will we do first to solve for y? The first thing we're going to do is subtract 6x from both sides. And then what do we get? We get 2y equals negative 6x. Now what do we do? We got to divide both sides by 2. And what's our final equation? Y equals negative 3x. So is it written as y equals kx? Well, it's not y equals kx, but y equals negative 3x. So yes, that is a direct variation. And the constant is the number. So what's the constant of variation? The constant is negative 3. And that's your final answer. So yes, it is a direct variation. K equals negative 3. So basically, you put it into like y equals mx plus b form, but if there's no b, then you're good to go. If it's just y equals mx, then it's a direct variation. And m is kind of like this, the constant is like our slope. M is our constant. So let's do example 2. What's the first thing we need to do to solve for y? The first thing we're going to do is subtract 12x from both sides, and what will that give us? That gives us negative 4y equals 8 minus 12x. Now what do? We got to divide both sides by negative 4, and what do we get? Y equals negative 2x plus 3. So is that a direct variation? Is it just y equals kx? No, it's not, and because it has that negative 2, then it's not a direct variation. It just needs to be kx. If that negative 2 was gone, and it was just y equals 3x, then we'd be good. But that negative 2 there messes that up. And now let's do example 3. Go ahead and solve that and let me know what you get. You should get y equals negative 3x. So is it a direct variation? Yes. And what's the constant? Negative 3. All right, the last example on this page, write the equation of a direct variation that includes the point 3,6. So when I say write an equation, that means I want the original equation. But we're going to use the secondary equation to help us out, okay? So I'm going to start with the secondary equation, k equals y over x, okay? And what I'm going to do is I need to find the constant first before I can write an equation. So I'm going to do k equals, and what is y in the ordered pair? Y is 3, y is 6, what is x? X is 3, so I'm going to do 6 over 3. What does 6 over 3 equal? K equals 2. So my equation, now all I'm going to do is write this first equation, but I'm going to plug in k. I'm just going to plug in k. I'm not going to plug in y and x. So my equation is y equals 2x. So go ahead and do the rest of this page on your own and check your answers, and then you can go to the next page.